at which point the rogue agent infiltrated a plastics factory in Malaysia and inserted the stolen nuclear bomb plans into the mold of a giant plastic, toy item, which was supposed to be shipped across the ocean to San Diego, where another agent would retrieve the smuggled plans. But thanks to bad weather along the way, the cargo didn't make it. So, for the past 2 years, the world's most dangerous secrets have been inside a piece of plastic, floating around somewhere in the Pacific Ocean.
Okay, first question. Just so we know what to look for, what exactly are these toy items that the secrets are hidden inside of?
Same question.
'Cause it seemed like you kinda didn't want to say.
Okay, fine. It was a shipment of giant garden gnomes. 100 Pilate gnomes, 200 DJ Khaled gnomes, 50 food poisoning gnomes. The list goes on and on. But just one air quotes gnome. That's the gnome with the smuggled secrets inside.
Sometimes I air quote so much my fingers get sore.
Last week, there were 3 gnome sightings off the Washington coast. Not the air quotes gnome, but it's a good place to start. And FYI, Mosa, we're not the only ones looking for these nuclear plans. If they fall into the wrong hands, it's TTYL, planet Earth.
No pressure or anything.
Something tells me... That's the boat we're looking for!
I was picturing more of a super yacht. Jacuzzi, disco lights, personal chef. When we first brought up the net, I thought it was a monster halibut.
I was thinking great white.
Who could have guessed it was a revenge gnome?
Apparently very popular with the broken-hearted.
Charming. And you caught it here? Where we're anchored now?
This very spot! Which means the other gnomes are right down there, where they fell off the ship.
Oh, honey, you need to take a better look at your file there. The cargo didn't spill where we are, near the Washington coast. It spilled way over here, near the Philippines. Last year, a few gnomes showed up off the coast of Japan.
And so far, Revenge Gnome's the first to cross the Pacific.
What?
Of course! The water activated their swimming powers!
The gnomes are hard plastic, kinda like a buoy. They float, but they sure can't swim.
So how'd they get from the Philippines to Japan all the way over here to Washington?
The water must have carried them in a current.
As in electricity or events?
Current as in moving water.
You didn't think the water in the ocean stays still, did you? Like a big bathtub?
Oh, no, no, no. Of course not. How silly.
Bathtub.
Why are we laughing?
A current is like a river. A lot of water moving all together in one direction inside a much bigger body of water. If you look at the ocean surface, you can actually see it.
A river inside water.
And if you go way down deep in the ocean, it gets even more exciting. Not only does the current turn and twist, it also rises up and drops, like a roller coaster.
Roller coasters? Somebody said my word!
Okay, so where does this current start? We've got a gnome to find and no time to lose.
Listen, Mosa, the ocean is huge with lots of different currents. You could spend years trying to find the gnome out there.
You need to know where to look, and that means knowing how currents move.
Fair enough. I can adjust my expectations. Okay, spill it. How do currents move?
Here's pretty much all we know. Currents are affected by wind, light stuff rising and dense stuff sinking, land, and the rotation of the Earth.
Why does it look like you're leaving?
You're not the first people to come out here asking questions. Between that and revenge gnomes stuck in our net, we're getting a little spooked.
Well, you could borrow our boat to find out more. There's charts and everything down in the cabin.
Good luck, kids!
Hang on. This is a matter of global security, not a scavenger hunt.
I feel like a baby lost in the mall on Black Friday.
Latest gnome found here. which means the air quotes no must be in one of these 4 directions. Drones, move out.
I don't think they work like that.
First, wind. How does wind affect current? Did you see that? The wind picked up and the boat moved.
So wind moved the boat? What does that have to do with water?
The waves got bigger, which means wind moved the water too.
Air moves water? Impossible!
Is it? Let's make a model to find out.
Oh, feel that beat, Revenge Gnome? This yacht is thumping.
I see waves on top, but all the water looks the same, so I can't really see what it's doing.
Presto changeo. Now we can see if wind moves water. Wind, you're up. The water is moving, and waves on top, and just below the surface too.
So all over the surface of the ocean, all over the world, wind helps make currents.
Which means if there's any chance of figuring out where the current is carrying that air quotes gnome with the smuggled nuclear secrets, we gotta figure out which way the wind blows. So here's what we know about wind. At the equator, the sun hits the earth head on, so there's more heat. When the air is warmer, its molecules move farther apart, so it becomes less dense, which makes it lighter. So it rises and spreads out away from the equator. Meanwhile, cooler air rushes in where the warm air used to be. Those molecules are much closer together, so the air is denser. And denser stuff is heavier, so gravity pulls it down.
Just like What's-His-Face said, dense stuff sinks. But where does the cooler air come from?
From someplace colder? Of course, the poles. So warm, less dense wind rises and goes from the equator to the poles. And cold, dense wind sinks and goes from the poles to the equator. And since wind makes currents, that's how the currents move too. Equator to pole, pole to equator.
And does water rise and sink the same way as air too?
Only one way to find out.
Kesha Gnome, Ichabod Gnome, wait up! Join the party!
So here's our water. So cold it's frozen, and thanks to some smurfishly blue food coloring, we can see it.
And I've just warmed up my vampirishly red water so we can see that too.
Cold water at the poles.
Warm water at the equator. And would you look at that?
Dense cold water sinks and spreads, pole to equator. Light warm water stays up above and spreads, equator to pole.
Just like air.
I love us.
Not so fast, Einsteins. Temperature's not the only thing that affects water density.
Mosa, the bait is talking!
If anybody knows the ocean, it's me. And you're missing one key ingredient.
Ingredient of ocean water. Ingredient of ocean water.
Ding, ding, ding. Salt. Okay, is our red water the same temperature as our blue water?
Sure is, bait. Only difference is how much salt.
Can we pour now? Can we?
Look, water with more salt sinks, and water with less salt stays up above.
So, more salt makes water denser.
And at the poles where it's cold, lots of water freezes. But the salt stays behind in the water that doesn't freeze. Which means...
Oh, I think I've got this. Water sinks at the poles not just because it's colder, but also because it's saltier.
And then it spreads, pole to equator, which I see you've already figured out.
And at the equator, warm water stays up above because it's less dense, and it flows equator to pole.
Now you got it.
I'm sorry I was scared of you, Bait.
Small fishing craft in distress. Adrift in the current and heading south. Appears to have been boarded and overtaken by... Well, I can't believe I'm about to say this.
So, if it weren't for currents and wind, all that heat that hits the equator would stick around down here, which would make this whole part of the world super hot. And up here, where there's not as much sun, it would be freezing. So currents are kind of like an air conditioner or a heater in a house. They regulate the climate of the Earth.
Mosa, currents can't save the Earth from a nuclear bomb. If someone else finds those plans before us, it's see you never life as we know it.
Sorry, but it makes sense, right?
One drone kind of hit a big wave out here, one hit Vancouver Island, and one hit that Space Needle thingy, and one hit like a typhoon down here.
And not a single gnome was spotted, which means air quotes gnome must be inside one of these 4 circles. Bring me Wikipedia!
So here's what we know so far. The current carried the gnomes from the equator, then north to the pole.
Just like our model.
But the gnomes went all the way across the North Pacific Ocean to Washington. That current isn't just going from the equator to the pole, it's curving.
Kind of like the land curves, too.
Land, of course. Number 3 in my notes. Look how the land makes the current turn. Some water hits land, but most of it curves around the land. I wonder if the water going north bumped into the land here and started curving east around here. The shape of the land changes the direction of the current.
Except, and trust me, Mosa, I know the sting of disappointment, but up here in the Arctic, no gnomes have washed up anywhere.
So the current goes this way, right across the ocean? Why? The way that current curves, it's beginning to look like a...
Mosa, there's something you need to see.
Oh, we just got a sponsor gnome.
Tell us.
I don't know what happened, Mosa. The music and the ocean, the gnomes and the jacuzzi. I guess I got carried away.
Literally. Any idea where we are?
Jacuzzi?
Not to stir the pot, but we were in the gnome's current. Couldn't we just keep following it?
Okay, I kind of agree. Doesn't global emergency trump Coast Guard rules?
Trust me, you're gonna find the air quotes gnome a whole lot faster using your notes than spinning aimlessly at night in the ocean. As reckless as they are, those 2 old-timers sure know their science. The gnome current is shaped like this because of the Earth's rotation. Mosa, you don't happen to play baseball, do you? So, imagine I'm at the North Pole and you're at the equator. I want to throw the ball right to you in a straight line. But when I actually throw it...
A little wide there.
Okay, you try.
Hey!
Happens to the best of us. Because the Earth rotates faster at the equator than it does at the poles.
What?
The ball, that's the wind. It doesn't go straight. Equator to pole, pole to equator.
I know. That idea was too simple to be true.
It turns because of the rotation of the Earth. And over time, it turns more and more and more.
Oh. Because the wind turns, so does the current. And that's why it crosses the North Pacific Ocean. Then land gets in the way and makes the current turn south again, down along the Pacific coast of North America.
And just above the equator, a big wind moves from east to west.
So, since wind affects current, the current moves east and west too? So the current's heading back almost to where it was before, which means all that same stuff is gonna affect it all over again.
Wind, land, warm, lighter stuff rising, and cold, denser stuff sinking, and the rotation of the Earth around and around.
And that, detective, is called a gyre.
A jar?
A gyro!
Gyre. The gnome current is a gyre, otherwise known as a spiral. And since we all know how a spiral works, we can predict with a pretty good degree of certainty the most likely piece of land on which the air quotes known and the nuclear secrets hidden inside will wash ashore.
Our team is on the way. Fine work, Mosa.
Air quotes gnome, I know you're over here somewhere.
I finally fixed the Wi-Fi, and there's kind of some bad news. Apparently, the good guys found the gnome.
What? Where?